Hello, Algebra 2 folks, and welcome to Solving Equations and Inequalities. You're going to need your notes, a pencil, and a calculator. All right, we will get started. So the first thing I need you to do is write down the learning target. The learning target for today is that you can solve multi-step linear equations and inequalities. Now let's just make sure we understand a few words in here. Multi-step means more than one step, okay? Any equations means I'm going to have an equal sign, okay? And inequalities means I'm going to have a less than sign, a less than or equal to sign, a greater than sign, or a greater than or equal to sign, okay? And then let's talk about the word solve. So that's on the next slide. Solve means to find the solutions or solution to an equation or an inequality. Okay, so for the equations that we're going to do today, we are going to find one solution. For the inequalities that we are going to do today, we will be finding multiple solutions, not just one. Okay, so another way to say what does solve mean is that you find the value that makes the statement in front of you true. So if it's an equation, like I said, it'll be one solution, so it'll be x equals 4. Now there's more equations out there where you're going to have more than one solution, but today with linear equations, we only have one solution. With linear inequalities, we have multiple solutions. So x is greater than 4. That means anything greater than 4 is a solution. 5, 10, 300, 75,000. Those are all the values. So there's multiple answers to that inequality. Okay, let's solve a couple of each and see the difference and kind of remind you about how to solve equations and inequalities. Okay, so example number 1. First thing we're going to do is we are going to use the distributive property. Okay, so we have 3 times x, which is 3x, 3 times 4, which is 12, negative 2 times x is negative 2x, and negative 2 times negative 5 is positive 10. All right, so we have some x's on one side and some x's on the other. So when we want to move things across the equal sign, we have to go ahead and do inverse operations. So we need to add 2x to both sides. Only when you cross the equal sign do you do inverse operations, right? These cancel out. I get 5x plus 12 equals 10. Again, I want to get that 12 to the other side. When we solve for an x, we get x's on one side, all the numbers on the other. So then we're going to subtract 12 from both sides. We get 5x equals negative 2. Opposite of multiplying, inverse operation would be dividing by 5. X is equal to negative 2/5. That would be the solution to this equation. There's one answer that makes this statement true. Okay, example number 2. Bring down the 3x. Okay, distribute the 2. 2x minus 6 equals 24. Going to go ahead and move the 6 to the other side. Means I have to do inverse operations. Okay, now 3x plus 2x. A lot of you like to use inverse operations here. We will not be using inverse operations when they're on the same side. If they're together and we don't cross an equal sign, we add them. We combine like terms. Okay, so 3x and 2x would be 5x equals 30. Divide both sides by 5. Because I'm crossing the equal sign, I do inverse operation. The solution to this problem would be x equals 6. There is one solution that makes this equation true. Okay, now let's do some inequalities. I'm going to change this inequality to a negative. So we have negative 2/7 x minus 2 is less than 10. I'm changing that because it's important for us to see something that happens with inequalities that didn't happen with or does not happen with equations. All right, so we have our inequality here. I still want to get x alone. So the first thing I'm going to do is get the 2 to the other side. I use inverse operations. So I have negative 2/7 x is less than 12. Okay, now I want to get x alone. I'm going to divide both sides by negative 2/7. Yikes, I don't like to divide by fractions. And we learned in 7th grade that instead of dividing by a fraction, what we can do is we can multiply by the reciprocal. So I'm going to multiply by negative 7/2 to both sides. I like that better. It looks better, it's easier to put in your calculator, you make less mistakes. These guys over here cancel, I'm left with x. Oh, yep, it's not less than anymore, it's greater than. And I take 12 times negative 7 and divide that by 2, and I should get 84, negative 84 divided by 2, which would be negative, I believe, 42. So negative 42, okay? So a big thing that you need to remember, big idea, is that when we multiply or divide, so if we divide or multiply by a negative number, you have to flip the inequality sign. Not sure why it did that. Sorry about that. You have to flip the inequality sign. Okay, so don't forget to do that anytime you divide or multiply by a negative number on both sides of the inequality. All right, the other thing that you need to know about when solving inequalities is that there's more than one solution. So this says x is greater than negative 42. All right, so how we show that is we sketch it on a number line. So we find out where 0 is. We figure out that this would be negative 42. It's not equal, so these are open circles, okay, which means not included. And then everything greater than 42. So what's greater than 42? Well, negative 42, negative 41, negative 39, negative 25. 10 is greater than that. So everything to the right of negative 42 is a solution to this inequality. So more than one solution would make this inequality true. Okay, so we will go ahead and do another one. But this time we have a compound inequality. So a compound inequality means more than one inequality. So you can see that there's 2 of them here. So if I covered this side up and I would just solve this side, I would subtract 4 from each side. Okay, but if I cover this part up, then I would subtract 4 from here and over here. So when you have a compound inequality that has 2 inequalities in it, you're going to subtract 4 from all 3 sides. Okay, so then this will become negative 8, which is less than 2x, which is less than 8. Our goal is to get the x alone in the middle. Okay, so now if I want to get x alone, I'm going to have to divide by 2. If there was just 2 sides, I'd do 2 sides, but because we have 3, we're going to divide by all 3 sides by 2. So negative 8 divided by 2 would be negative 4, and then this side would be 4. Now notice, I'm not dividing by a negative. So because I'm not dividing by a negative, I do not flip the inequality sign. Okay? So this would be negative 4 is less than x, which is less than 4. Okay, 8 divided by 2 is 4. I think I had a 1 there on accident, but that should have been a 4. All right, so now we are going to draw this on a number line to show all of our solutions. Okay, so where's negative 4? Roughly here. This is 0. This is 4. Open circles because they're not equal to. If they had the little equal to, then we'd have closed in circles. This says x is between negative 4 and 4. So all the solutions that would make this true would be everything between negative 4 and 4. Okay? Right, let's try another compound inequality. This time the compound inequality is an OR. So the answer is either here or it's over here. There's no intersection, like the last one had an intersecting area. Anything in between them was a solution. Now it's one or the other. So you solve each one of them separately. So 2 times x would be 2x. 2 times negative 3 would be negative 6, which is less than or equal to 6. Add 6 to both sides. 2x is less than or equal to 12. Divide by 2. X is less than or equal to 6. Again, we didn't divide by a negative, so we don't flip that inequality sign. So the answer is either x is less than or equal to 6, or, okay, let's see what happens here. Add 11 to both sides. 3x is greater than 21. X is greater than, divide both sides by 3. X is greater than 7. So it's one or the other if there's not an intersection. So what does that look like on a number line? Well, here's 0. Here is 6. Okay. And then here would be 7. All right. So x is less than or equal to 6. Closed circle because I have an equal. And everything less than that. Okay, so it's all of this forever. And then this says x is greater than 7. So everything to the right of 7, not including 7. So you can see the answer would fall here or the answer would fall here. It's not an intersection. Okay. So we have solved equations. We've solved inequalities, where it was a regular inequality, a single inequality, and 2 different compound inequalities. And we've sketched the graphs of the solutions of inequalities. That's all I have for you today. And so tomorrow we can come in and do some marker boards. Have a great day, and we will learn some more tomorrow.